Hello, my name is Robin Surf, and we are at Module 3, Math for Teachers 2, Chapter 10. So let's go ahead and take a look at our first question. Are you able to convert from one unit to another? How many mouthfuls are in one gill, 1 pint, and 1 cup? And looking at the gill, you will use the chart to see that 1 gill equals 2 jacks. 2 jacks will equal 4 jiggers, and 4 jiggers will equal 8 mouthfuls. We do the same thing for 1 cup. We know 1 cup is equal to 2 jills. And since we just calculated 1 gill, 2 jills must equal 16 mouthfuls. So let's take a look. And we also know from the chart that 1 pint equals 2 cups. And since we just calculated 4 cups, then 2 cups must equal 32 mouthfuls. So let's take a look. We are going to continue with question 1. So are you able to convert from one unit to another? Well, let's go ahead and take a look. If 1 mouthful, 1 jigger, 1 jack, and 1 gallon are poured into the pail, is there room for any more? Here is what we can figure out from the chart. 1 pail is equal to 2 gallons. We can use the chart and convert 1 pail all the way down to 32 cups. 32 cups will equal 64 jills. Let's take a look. Converting all the way down to mouthfuls, the pail will hold 256 mouthfuls. Now, we want to add to the pail 1 gallon, 1 cup, 1 bottle, and all the way down the list. What we do is convert each of the units to mouthfuls. When adding up all the mouthfuls, we pour into the pail. So we have added 255 mouthfuls. And since the pail can hold 256 mouthfuls, that leaves room for 1 more mouthful. Let's go ahead and take a look at question 2. Can you find the area in the perimeter of the below triangles? The question would simply like us to find the perimeter and area of each of the triangles you see here. I created a small chart to assist in completing this task. The perimeter solutions are found above the black bar, and the area solutions are found below the black bar. The yellow highlights the actual solution, and the green are the numbers used to find the solution. So hopefully that can help you visually find it. If you look at the green portion next to the perimeter row, you will see for each example that we simply took the 3 sides of each triangle and added them together. You can each check my work if you would like. For the trickier part, we need to find area. And area of a triangle is simply defined as the base times the height divided by 2. The first one is fairly straightforward with 82.3 as the base and 41 as the height. For part B, we should already understand that the hypotenuse is given a right triangle. So we know the other 2 sides will make up the base and the height. The last looks more difficult than it is. So just remember that we simply need only the base and the height. We already know the base to be 6.2. So what is the height? Well, they give us the number as well. The height is 2.6. Anyone can check my math if they would like and ask any questions. But I need to point out that when working with the area of the triangle, your answers will always include units squared. Let's go ahead and look at question number 3. Which is larger, the area of the region between the circles or the area inside the smaller circle? Well, what we know is that each of the sides of the square are 10 units. We also know that the radius of the circle will be 5, or 1/2 the distance of one of the sides of the square. The area of a circle is A equals pi r squared. So the area of the smaller circle, after doing the math, is 78.5 units. And then we can draw a triangle which looks like this. And then we can draw, now, notice the hypotenuse is also the radius of the larger circle. When using the equation a squared plus b squared equals c squared, the hypotenuse comes out to be 7.07. So if you use the equation a equals pi r squared for the larger circle, then area is equal to 157. When we take the area of the larger circle, which is 157, subtract the smaller circle, 78.5. We get the space in between, which comes out to be exactly 78.5. According to these numbers, the smaller circle contains the same amount of space in between circles. Let's go ahead and move along. And question 4. Are you able to show that the ratio of the volumes of the cone, sphere, and cylinder is 1, 2, and 3? Well, let's go ahead and take a look. We can start by finding the area of the pyramid. Since I am not using numbers, we will just call the base B and the height H. The volume of the pyramid is 1/3 BH. The base of the cone is a circle, and the area of the circle is B equals pi r squared. If we use the original volume of the cone equation, we can find the full volume of the singular cone to be 2/3 pi r third. Next, the volume of the cylinder is equal to base times height. But the base is also the area of the circle. So we can substitute 2r in the height and pi r squared for the base. We end up with 2 pi r to the third. And we know the volume of the sphere is 4/3 pi r 3. So here is what we have so far. Let's take a look. All right, so next, to prove that the volumes are 1, 2, 2, 2, 3, we must divide each equation by the volume of the cone. So the volume of the cone divided by the volume of the cone is always going to be 1. Any number divided by itself is always 1. Remember that. If you take the volume of the sphere and divide it by the volume of the cone, the only number you're left with is 2. So if you take the volume of the cylinder and divide it by the volume of the cone, the only number remaining is 3. So the cone to the sphere to the cylinder ratio is 1, 2, 2, 2, 3. Let's move on to question number 5. Let's take a look. Can you find the surface areas of the 2 figures below? Well, for the first shape, our original formula to use is SA equals 2B plus PH. So let's take a look at our diagram. What this means is that our surface area is equal to 2 times the area of our trapezoids, plus the perimeter of one of the trapezoid sides times the height. So let's find the area of one of the trapezoid sides. We take the 2 parallel lines and add them together to get 43. Those 2 parallel lines are considered the bases. So then we take 43 and we multiply by the height, which is 4. Then we divide that number by 2, which gives us 86. But always remember, we have 2 trapezoids in this figure. So we multiply 86 by 2 to get 172. Now the perimeter of one of the trapezoids is 70, and we are given a height of 4. So we plug these numbers into our equation, and the surface area is equal to 452 centimeters squared. In the next figure, let's take a look. The 2 bases are triangles, and the area of one of those triangles is equal to 1/2 times the base times the height, which comes out to be 60 meters. So now the perimeter of one of those triangle sides is 40, and we know the height is equal to 8. So if we use the same formula, let's take a look. Surface area equals 2 times 60 plus 40 times 8. So our surface area is equal to 440 meters squared. Let's go ahead and move on to our next question. And this is question number 6. Are you able to find the surface area and volume of the solids? Well, the first thing we can notice about the first picture is that it is actually one cylinder with 2 half globes on each end. The half globes can come together to make one singular globe, which is kind of neat. The surface area of the sphere is S equals 4 pi r squared. We already know the radius, which is just half of 8. So r is equal to 4, and then S will be equal to 64 pi for the entire globe structure. So the rectangular part of the picture is calculated by using 2 pi RH, where r is the radius and h is the length of the cylinder. We already know r is equal to 4 and h will be equal to 21. So substitution will give us 168 pi. Add the globe of 64 pi to the 168 pi and get 232 pi, or roughly 728.48 feet squared. The volume is used with the calculation here. Let's take a look. Simply substitute r in for the equation along with your height to find the answer. Now let's take a look for the second picture. The surface area is the sum of the exterior of the cone, so the cylinder and one of the circles on the end. The equation will look like this. All right, so R is equal to the radius, S is equal to the slant length, H is equal to the height of the cylinder. So input all of the necessary values and you should receive a surface area of approximately 175.84 meters squared. The volume is given by this equation here. Use the same values as before, only this time you will enter the height of the cone and the height of the cylinder. Thank you for joining me, and I hope you have a great day.